we have entered a completely new world when it comes to electronic warfare. I mean, full disclosure, I was an electronic warfare signals intelligence soldier on the East-West German border during the Cold War in the early 80s.
Wow.
And we were still using hoop antennas for radio direction finding until they deployed the Trailblazer. It was all analog back then.
Things have changed a little bit since then, but when you think about the state of modern warfare, even having those analog backups, still a good thing to have. But of course, radio waves, light, still analog to some extent. Of course, light being particles and waves, but analog still has its place, no doubt.
Well, I think that's one of the challenges in designing military aerospace systems, because not only do they have to meet the operational requirements, they have to operate in an analog world. I mean, often a challenging and harsh environment, analog world.
Absolutely. Yeah. So one of the things that differentiates suppliers like General Microsystems and our peers, our embedded peers in this space, is the ability to build rugged, long life cycle deployable solutions. You'll see lots of suppliers of electronic hardware from the industrial segment. We would argue that the industrial segment is not nearly good enough most of the time for the battlefield. But that does bring some opportunities and technology changes to the battlefield. When you look at pure commercial technologies that are out there, how can you adapt those to deploy those on the battlefield to get the best and the latest of technology while still meeting the requirements of the battlefield? That is the challenge for sure.
The modern battlefield is also evolving in different ways with different application spaces even. I mean, back in the day, the primary things were intercept, we'd listen, jamming, we'd jam. That's pretty, I mean, there were other aspects of electronic warfare as well, but I mean, it was way more opportunistic. And today now it's ubiquitous and pervasive. Everything involves some form of electronic warfare at this point, I believe.
So let's pick up on the two trends you just mentioned. You listen and you jam, and then you apply some intelligence to the data that you get. So the operators involved, or a string of operators. Perhaps the biggest thing that's changed, many things have changed, but the biggest thing that has changed from what you described earlier, and just using those two vectors, is the connectedness of the battlefield. It isn't quite a cliche yet to say that there is this thing called the connected battlefield, because the US DoD and various MODs around the world have been talking about battlefield connectivity, or the digital battlefield, literally for decades. But what's changed today, and is even changing just this year in 2024, is the ability to have sensors, interceptor devices, or even jamming devices do what they do, and then take that information and move it elsewhere on the battlefield to share that information with other friendly assets, to use that information for reach back all the way back to a command post, maybe a talk on the battlefield, or all the way back to the continental US or CONUS, so that the commander in chief can make some decisions. So there are changes at the sensors, changes at the processing nodes, but it's the connectivity and the connectedness of all of these sensors, all of these assets on the battlefield, that is truly multiple orders of magnitude of game changers on the battlefield when you talk about electronic warfare and the digital battlefield.
I couldn't agree with you more, Chris. I mean, there was an old joke in the back when the internet was growing and before creating the first true connectivity that people experienced. That one
Mhm.
of the jokes was the internet turns everything it touches into the internet, and now it's the cloud, and the cloud has now covered the earth, as it were. If you're in an application space, and in military aerospace, you're talking the highest stakes of them all. There's no second place in that. Well, there is, but the trophy is really small and it's not worth much. It's a life and death situation oftentimes. And now you're throwing in the complexity of interconnectivity. You're throwing in a busy elect- wireless electronic environment. I mean, just the noise alone.
Yeah. So let's talk about connectivity. The U.S. still has assets in inventory today, assets that are being upgraded and still deployed. And one of the key functions of those assets, like an AWACS, is to do interoperability between what are called joint battlefield assets. One of the things that an AWACS will do is basically do radio bridging between U.S. Navy assets, Army ground assets, and Air Force airborne assets, because they don't all use the same waveform to communicate. Sometimes it's as simple as you've got assets on the ground who are calling for fire or for calling for a weapon to be placed on a target, but they cannot directly communicate with, say, an F-18 or an F-16 that is inbound to take out that target. Or they can't directly communicate with a reachback with a Predator operator somewhere in Nevada to bring that weapon onto the target. So you use an asset like an AWACS or some other intermediary that sometimes literally will just bridge the radio communications, or even in a pinch, just repeat what they heard an operator say and pass that information along the line. But that's starting to change. One of the things that's changing that is the ability to have a standardized U.S. military data link, data waveform. So you may have heard of the Link 16 radio. The Link 16 radio is being deployed more and more frequently for what the government calls high rate data communications. And high rate is not in the gigabits per second, it's in the megabits per second. But that's still orders of magnitude faster than, say, Army tactical SINCGARS radios. But the Link 16 radio has now become much more miniaturized with small modules that you can put in portable equipment, or with small form factor modules like GMS provides to a number of primes, to where you can take that Link 16 radio, embed it in an airborne asset, embed it in a ground vehicle asset. Now you can share digital data for that connected battlefield. So just something as simple as a common across the military digital waveform with low power portable radios to share that data is a real game changer.
I can easily see that. In fact, one of the things that ideas about that I've been toying with, because working on my second novel, got to put something interesting in there about the modern battlefield. And I had proposed that, not too far into the future, you could have, say, for example, a pilot who's run out of ammo see an infantry company below and say, hey, launch your drones, boys. I want to take them over and take them onto the, enemy, as it were. And they just launch their drones, and the pilot takes over with, his comlink, and bang, now the pilot's got combat drones again to deploy against the enemy.
Yeah, in fact, that's very much possible. There's a technology I'd like to talk about with you today that is going to make that a lot more ubiquitous across the world. But you just made me think of something that's somewhat the inverse of what you described on the digital battlefield, and that's something called manned-unmanned teaming. I don't know if you've heard of that. So MUM-T is kind of a generic term where you've got some sort of a digital asset. Usually it's an autonomous digital asset that is teaming up with a person, such that the two of them together will prosecute their mission with a lot more success. So the Army has a program that's of the same name called MUM-T, manned-unmanned teaming. And what it is basically it uses various U.S. Army drone assets, such as a Gray Eagle, which is a version of a Predator, connected to an AH-64 Apache attack gunship. And what the MUM-T program does is, the Apache is a two-crew aircraft. There's the pilot flying it, and then the weapons officer that sits lower in the nose that controls the Apache's weapons. Well, now with manned-unmanned teaming and that Predator or other Army asset that flies ahead, the two of those together can perform the battle much, much better. The Predator has longer standoff weapons because it can fly further ahead of the Apache, and it's obviously much more expendable than the Apache with two crew. So now the Predator is an extension of the Apache's weapon systems and battlefield sensors. The Apache and the Predator can both lay down weapons, but now this dramatically improves the weapons officer's view of the battlefield and makes the Apache that much more lethal because it's now got a wingman, the manned-unmanned teaming concept.